Welcome to Path to Math. Let's cover logarithmic integrals. In this video, we're going to be covering integrals with logs that have linear equations inside the logarithm. The base value doesn't really matter. So I'm going to show you first the formula involved with finding the integral for any logarithm with a linear function. I'm going to use A and B to notate the base and the inside of the logarithm. We want to take the inside of the logarithm and multiply it to the front. So we have b times log of base a times b over e. We don't want to get rid of the inside. Instead, we just want to divide it by e. E is a irrational constant, and that is approximately 2.7. It's also a button on your calculator. So if you need to simplify that, you have your calculator to help you with that. All right, after we divide the inside by e, we want to divide the entire term by the derivative of the inside. All right, so let's do an example and put this into practice, but you're going to want to write this down. You're going to want to have this memorized for any linear function. Let's go over really quickly linear functions. That's going to be x, 3x. That could be 5x plus 4. That could be 17, let's say negative 17x plus 20. All of those are linear functions. The key consistent thing that you want to look out for is the exponent of 1 on the variable. And there's going to be situations where we can actually force the function to have an exponent of 1. I'll go over that at the end of the video. Let's do some practice with this formula. Let's practice the integral of log base 7 of 5x dx. The first thing you want to do is take the inside and multiply it out front. So we have 5x log base 7 times 5x over e. Again, we don't want to get rid of the inside. We just divide it by that constant, e. This is all going to be divided by 5 because the derivative of 5x is equal to 5. And of course, with every integral, we can't forget the constant. So we have 5x log base 7, 5x over e, divided by e plus c. If you're looking to prove these integrals and to prove the shortcut, if you're in the part of calculus where you need to provide the proof of why we can use this shortcut, I'm going to make another video on how to use change of base to complete and prove these integrals. But that'll be a whole different video, and I'll post that link down in the description below when I do post that. Let's say we have two terms in our integral. It's all the same process, so follow along. We have 5x plus 9 being multiplied out front. Here's our log. We take the 5x plus 9 and divide it by e. And we divide all this by 5. Again, in this case, we have the derivative of 5x plus 9. But that's just 5. So in our denominator is the 5. So from here, I could just add the plus c. Some teachers would appreciate if you rewrote this one more time, a little bit simpler. We could have 1/5 on the outside. And then this way, we could get rid of this giant fraction. And instead, we could take the denominator and we could pull it out front, basically. And so we have 1/5 of 5x plus 9 times log base 3 times, or of 5x plus 9 over e plus c. And that would be a proper final answer. Let's use the power rule to help us make the exponent equal to 1 in some situations. So, for example, we might have the log of 9 of x to the 4th power. If we have an exponent like this, we have to get rid of that. We have to somehow find a way to make that 1. And because of the power rule, or the power rule with log, we could take that 4 and we could put it out in front of the integral. We could actually multiply the 4 to the front. So we get 4 times the integral of log 9, base 9, times x. And now we can use that shortcut that we've been practicing in this video. We just have a 4 out in front. So we have 4 times x times log base 9 times x over e all divided by 1. Because in this case, the derivative of x equals 1. So let's do 4x log 9, base 9, x over e plus c. All right, so again, in some cases, when you have one term, you're able to take that exponent that's on the variable and multiply it out front first. That makes your life a lot easier, because then you don't have to deal with integrating a quadratic or any type of other function within the log.